So, ladies and gentlemen, I wish you good luck and an interesting day, and we can start with our first guest. And let me introduce you, Dr. Ashkan Fardost. Ashkan, welcome in Riga.
Thank you. Thanks for having me.
You have made yourself comfortable, I hope.
Yeah.
So do I. So, dear audience, ladies and gentlemen, boys and girls, I really encourage you to ask questions to Ashkan, as I said, via the comments section of the platform. And you've been introduced already when you did your keynote speech. Thank you so much, Ashkan, for that. It was
my pleasure.
Really.
Congrats on the new position, by the way.
Sorry?
Congrats on your new position.
Thank you.
Yeah.
Thank you. It's really exciting. Your speech was absolutely excellent. And
Thanks.
I must say to the audience that Ashkan has been nominated as the Speaker of the Year in Sweden a couple of years ago, right? And he's one of the most asked speakers worldwide. And we have the fantastic opportunity to bomb him now with all kinds of questions. And literally all kinds, not only concerning his professional duties, but, well, you will not mind, I hope, if they ask you, for example, what's your favorite food?
Anything goes. While we're waiting for the questions, what do you think about the 150 years lifespan thing?
Well, I hope that that's true.
Really?
Yeah. 150 sounds pretty logic to me. Well, taking in account what we are knowing already about humans. But if we talk about a lifespan beyond 150, then that sounds already quite fantastic to me.
Do you want to live 150 years though?
Frankly speaking, no.
Why not?
Well, it will depend, of course, of the stage of health of the person which reaches that age. If you are in a bad shape, let's say, and you can't do anything and you can't enjoy life, then what's the point of?
No, but I mean, if we assume, like, when you're 70, you feel like you do when you're 30, right? If the lifespan is 150, then 70 should be the new 30, something like that, right?
Yeah. Ladies and gentlemen, we are waiting for your questions in the platform, but I was going to ask you the simplest questions we usually ask to a person which is a guest in our country. Is this the first time for you in Riga?
Yeah, first time.
Aha.
Yeah.
And have you got some time to run around the city and...
Yeah, I've been walking around, like, looking at the architecture. Unfortunately, there aren't that many people outside. So, and I usually go for the people, but I try to do the best I could.
Yeah, it's not possible nowadays, unfortunately. Yeah, I should actually tell the audience that today at the conference, everybody who entered this room was tested with the express test for SARS-CoV-2 antigen, and everybody in the building is negative. And also, we keep the distance, and only those persons speaking on stage are not wearing masks. So I hope, or let's say I'm pretty sure, we are really safe here. I was watching one of your talks recently. It was the TED talk in Berlin. And it was the one you were talking about pharmaceuticals, which most of them do not actually cure anything, and that the new big hope in medicine would be genetic technologies, gene therapy, and things like that. And one thing was really interesting to me. You mentioned these S-curves.
Right.
That different technologies, they start slowly, then is the exponential phase, and then they slow again because they are running out of, I don't remember what it was, but
they run out of juice, you know? You reach the limit of that particular realm.
Yeah.
Just like with vacuum tubes in the early days of computing. Like, there's a physical limit to how much power you can get from that. And in a sense, we're reaching that limit with current microprocessing technology as well. The distance between the transistors. I think we're down to 5 nanometers, something like that. But it hit me because I took my master's in pharmaceutical sciences before going on to organic chemistry. And while I was studying, I looked at what's the output from this field? Tackling medicine from a chemical perspective. So I downloaded the entire database of the United States FDA. And there were thousands of compounds in there that have been cleared for market. And I started categorizing them to see which of these compounds actually cure stuff and which of these compounds don't cure stuff. And if they don't cure, what do they do instead? So what I found was, depending on how you count, roughly 95% of every pharmaceutical compound out there, it doesn't cure anything.
They are fighting the symptoms.
Fighting the symptoms. And then I looked at the best-selling drugs on the market. All of those drugs, majority of them, didn't cure anything either. So then I started thinking, why are we still doing this? Why do we have lead times of roughly 15 years, pouring billions into R&D to get a compound that does the job a little bit better than the last? Shouldn't we try to start leaving this behind? Again, I'm not undermining the enormous amount of help these compounds provide for people who need them. I'm not against that per se. But what I'm saying is maybe we should look further and start looking at curing stuff. And I would say now we have the beginnings of that technology in our hands, not least thanks to Cas9 and CRISPR technology. So we can actually get to the core of the diseases that we're experiencing.
We are going to have a nice discussion later today concerning CRISPR-Cas9 on this stage. So I hope we'll learn some new things about it. But returning to these S-curves,
yeah.
According to you, it seems that the information technology curve has reached something like the slowing phase, right, at the moment?
Yeah, it seems like that. I mean, when we were down to, I think, 10 nanometer distance between transistors, a lot of people thought that this is the end of microprocessing development as we know it. So, there are a lot of different other avenues to tackling that. For example, using nanotechnology, you can build different kinds of transistors on a molecular level. But I mean, Apple, I think, is down to 6 nanometers, something like that now, with their new M1 chips. So there seems to be a little bit more juice to squeeze out of that avenue. But eventually, I think, we're reaching the actual physical limit of the transistors right now. But again, I'm not worried because historically speaking, we've gone through these S-curves so many times.
Mm-hmm. So something new should actually come in that field. I'm asking because, as to my mind, all the progress, that exponential progress in the fields of genetics actually coincided with the exponential growth of information technologies.
Yeah.
Because some 30 years ago, you couldn't imagine actually that it would be possible to deal with that amount of data you get from DNA sequencing, for example.
Exactly.
And you can't process that data without very powerful computing powers. So you said that the next big thing is genetics, and it will grow and grow and grow faster and faster, and the expenses will be reduced year by year. So isn't there some kind of controversy that there is a limit for the IT at the moment, but the genetics will expand more and more?
Well, I don't think we've reached the limit of IT in terms of using current information technology or microprocessing power for genetics. So just because computing power might reach its limit with current microprocessing technology, that doesn't mean that we've squeezed out all of the juice in terms of what we can do with genetic information. And taking into account the developments in machine learning, for example, we can use that to tackle many of the questions we have in genetics. Because genetics, it's a non-linear dynamic problem. It's not this system where one gene leads to one function. It's not discrete like that. You know this better than me as a molecular biologist. It's fractal, right? One set of genes can code for a myriad of different functions in the body. So you can't just shut off one gene and hoping a disease will be cured. You might be shutting off 5,000 other functions that might kill you instead. So I think there we have machine learning, for example, that can come very handy. And now we're just seeing the beginnings of quantum computing, which is an excellent technology for attacking nonlinear problems. So there are developments being made that at least makes me very optimistic.
I see. Ashkan, sorry, as to our survey, ladies and gentlemen, there's just some more minutes, a couple of minutes, if you want to participate. Did you put your answer in the survey?
No, I didn't actually.
No, you don't have a computer now.
Not with me right now.
But if you could, which one would it be? Yes, it's nice. No, I don't care. Let me remind the question to our audience. Do you believe that development of medical technologies and genetics will lead to the moment when humans will be able to live 150 years or even more? So.
Well, I mean, technologically speaking, I don't see why it shouldn't be possible. But then the question is, every time we change the dynamics of human life, there are so many unintended consequences around it. Let's take an example. So in Sweden, where I'm from, I don't know how it is here, the age at which people have children is just increasing, right? So today, if you live in Stockholm, it's not uncommon to be like 34, 35 and just start thinking about having kids. And I'm thinking if we have a lifespan of 150, maybe we push that age up even more. So one unintended consequence of this is the fact that we as human beings, we become much more risk averse the older we get, right?
Exactly.
When we get past 30, something like that, we start to become very conservative, risk averse. And you can see what effects that have on child rearing, for example. 100 years ago, you might have been 20 or something when you got your first kid. You're not that risk averse yet. So you let your kid, roam around, do some dangerous stuff, get into accidents, which is part of growing up. Today, when I look at parents in Stockholm, they're 35, they have their first kid. They're super risk averse, they're ultra careful, very conservative. They don't let the kid do anything. They're super protective of the kid. And, this is not good in a way of growing up. You're supposed to hurt yourself. You're supposed to end up in a dangerous situation. So that's one of many unintended consequences of doing this. So I would say before we can track all of the parameters, or at least some of the parameters, it sounds good to live for 150 years. At the same time, it's a very narcissistic thing. Like, why should I live 150 years?
Exactly.
Right?
That's what I think.
I need some stress. Otherwise, you don't do anything. You just end up being lazy. So, I'm not conservative in many areas, but in terms of lifespan, 100 is enough.
That reminds me a nice joke which was circulating on the net recently about the generation of myself, let's say those who were born in the 60s last century, that according to today's rules and principles, as you mentioned, it's really a wonder we survived because we were doing everything dangerous in our childhood. Ladies and gentlemen, 1 more minute left to participate in the survey. Yeah, and let me see the results so far. It's approximately equal between the answers. Yes, it's exciting to live up and beyond the 150. Yes, but I don't see much advantage in it, and I have no idea. And those ones who say that there's a line science cannot cross, those are the minority, just 13%. Okay, we've got some questions. Ashkan, for example, this one. What future do you see for cancer treatment? And when do you think we will be able to cure cancer?
Well, that's a tough one because, the more synthetic things get in our environment and the longer we live, the more you increase the chances of getting cancer. So that's one aspect of it. But on the other hand, the mechanism behind cancer, it's pretty universal, right? We see the same patterns in different kinds of cancer. Correct me if I'm wrong. But you know, at the core of the problem, it's about uncontrolled cell proliferation. And if we take into account, you know, what we can do with genetics today, I don't see it as an impossibility to be able to find the actual mechanism behind it and just shut it off. It seems pretty straightforward once we get that resolution of manipulating genes in a high enough resolution. So I would say if genetic science continues to develop at the pace it's doing today, it wouldn't be that impossible to have it cured within the next 50 years.
Within the next 50 years. That's fair enough. Thank you. Another question. Ladies and gentlemen, Ashkan is also an investor, right?
Yeah.
You are running your own investment company, Oddballs Venture, right?
Yeah, it's so small scale, but it's tech.
Yeah, that's probably why Georgie is asking this. What is the best strategy of development for a preclinical stage biopharma startup? Look for investments independently or cooperating with big pharma?
Well, I'm not the right person to answer that because I haven't invested in pharma at all. Because for me, it's just too high risk, so I don't do that. And my big bet is that mental health will be a big thing in the next coming 20, 30 years. So the majority of my investments are in mental health, not from a pharmaceutical perspective, but from a therapeutic perspective. So I wouldn't want to give any advice on the specific topic of pharma because I have no track record to show. Mm-hmm. I don't want Georgie to lose their pension and stuff like that, you know.
I see. I was asked before by some colleagues here at this stage, if somebody wants to invite you as a speaker, what should they do? Contact you personally, or?
If you just Google my name, you will end up at the speaker bureau that I'm working with. It's a speaker bureau with 8 speakers based in Sweden, but we work globally. So if you just get in touch with them or send me an email, I'll put you in touch with them. Mm-hmm. I'm very available online. I'm all over the place.
Yeah. Then there's a question which says, on your CV and on your homepage, it says that your nationality is Svensk.
Yeah.
But by your origins, I guess you're Persian.
Yes, I'm born in Iran in '85. Then my parents came to Sweden in 1986. So they escaped the Iran-Iraq war, but also the theocratic dictatorship that took over the country.
I see. Do you still speak Persian?
Yeah. I spoke Farsi at home with my parents, so I still speak it, and I can read and write, but maybe at the level of a 10-year-old, so it takes a little bit of time. But yeah, I still have it with me.
Yeah. I did the practical part of my PhD in Stockholm.
Really?
Let's say,
which university?
At Huddinge Hospital.
All right.
Department of Clinical Virology, and I had a lot of colleagues from Iran. And,
yeah.
Some very, very good friends. So nice to see again in Riga.
I mean, white coat professions are very popular in Persian culture. You know, doctor, dentist, science.
Mm-hmm. If we return to your keynote speech, at the very end of it, you mentioned that the future belongs to those enterprises which are dealing with, which are developing products for special, let's call it digital tribes, as you called them, and did I get it right that also the future belongs to those which are open to sharing information and giving away the knowledge for free, let's say.
Yes,
so.
Because anything that can become digitized will become digitized, and everything that's in digital format can be copied. So if we can figure out a way to create the monetary value beyond the actual information, I think you can do much more interesting products. So the example I showed was Open Bionics. They share their 3D files, circuit board designs, everything for free. You can take Tesla. You know, Tesla is on the stock market, yet in 2014, they released all of their patents. They said, you know, our vision is a world free of dependency on fossil fuels. So it was kind of like a taunt towards the other car makers. Like, don't blame this on innovation. Here's all of our patents, use whatever you want, and build an electric fleet of cars. So what they monetize on today, I would say, is the fact that their product is never finished. You know, when you buy a Tesla, 6 months later, your battery power increases all of a sudden because of a software update. Its autopilot capabilities all of a sudden increase because of another update. So it's a dynamic product that keeps developing based on feedback from the real world. And I think that's really the power of Tesla. And that's what they're making their money on. All of their patents are out there for free. Anyone can use them.
I see. So, ladies and gentlemen, we've got a couple more minutes for questions. Kindly ask you to use that opportunity. Un momento. Let me refresh the page and...
I mean, it's
yes.
the same with open insulin. I mean, if you're into the field of medicine and tech, you should Google open insulin. What they are building in terms of insulin production is amazing. Again, the information is free, but whoever figures out how to mass produce insulin using the protocol, they can cash home the check. But the information in itself is free.
Thank you. Okay. Another question. What future do you see for mental health and how to improve it now?
So this is a big one. I mean, every time a new information medium has replaced an old one, it's been a very traumatic process. So when written language and agriculture came along, it was a very traumatic process with many different dark ages in between before we reached the situation we have today with mass production, industrialism, and so on. And I think the internet will unfortunately start another traumatic process because gradually people will have to accept the fact that we aren't isolated individuals. That's just a myth. There is no evidence in neuroscience or anything related to it that we are isolated, rational individuals. That's a myth proposed by René Descartes 400 years ago. And it was a good myth. You know, it worked really well. We built democracy, we built a nation state. All of that relies on that myth. But the internet kind of destroys it. And I think that is part of the explanation of all the chaos we see today, the increase in mental health disorders. People are confused. They feel that the world is in chaos because nobody has monopoly on the truth anymore. So I think in the next 40, 50 years, it's going to be really hard for people to orient themselves in the world, and that's going to cause a lot of mental health problems. And my advice would be, you know, try to get to know yourself, the body you're born with, the brain you're born with, figure out what are your talents, what are your strengths, what are your weaknesses, and start proliferating those strengths, and find one or several tribes online where you can contribute with your strength to that tribe, and you find meaning from there. Because the nation state is not going to be able to provide that meaning for you anymore, as it used to do. You know, this idea that you should have a education, career, pension, die, and everything will be fine. And you're going to get this, you know, self-realization at some point in your life. That's also a myth. So I would say figure out what's your strength, find the tribes that you can contribute to, and find your meaning in that tribe.
Okay. Thank you so much, Ashkan.
Thanks for having me. Thank you.
We have run out of time. Right. Ladies and gentlemen, Dr. Ashkan Fardost from Stockholm, Sweden. Thank you again.
Thanks so much. Thanks.
So, we've got a break now for 15 minutes on the MedTech stage, and I kindly invite you to be back in a quarter of an hour, and we will proceed with a wonderful and very interesting presentation about artificial spider silk.